This video is all on absolute value inequalities. So in our first two examples, we're going to look at the line graph that they give us, or the number line that they give us, and we're going to write the absolute value inequalities for each of those two. And then in examples 3 and 4, we are going to solve the absolute value inequality and then graph them. So the first thing we need to remember is how is an absolute value function written, inequality written. So for the absolute value, we're going to have our absolute value here, and it's always going to be x minus whatever the middle number is. When I say the middle number, I'm talking about like the number between the 2 points. Okay, so the number between the 2 points here is a -2. And then it's either going to be greater than, less than, greater than or equal to, or less than or equal to, and then the distance from the middle number to the points. So for this one, I have, they're going in opposite directions. So I know this is an OR, which means greater. They're filled in circles, so I know I can equal it. And then the distance from -2, so the distance from the middle. Okay, so I'm going to start off with my absolute value, x minus, I know this is greater than or equal to because they're going in opposite directions. The middle number is a -2, and from -2 to get to -1, or from -2 to get to -3, they're a difference of 1. They're one step away. Now, I don't want to have my answer like this because I can't have us subtracting a negative number. So the absolute value would end up being the absolute value of x plus 2 is greater than or equal to 1. Now, I can prove that that would be correct because if I choose a number, let's choose a number that's on one of the lines. So if I choose 0, if I put 0 in for x, 0 plus 2 is 2. The absolute value of 2 is 2. 2 is greater than or equal to 1. So it is bigger than 1, so that works there. Now, if I put a number that is less than -3, less than or equal to -3, let's just say let's put a -3 in there. -3 plus 2 is -1. The absolute value of -1 is 1. 1 is greater than or equal to 1. Since it's equal to, it satisfies that equation. Example 2. Here you can see that they are connected, so that means it's going to be a less than. And one easy way to think of it is less than. Less than, you hear like the and. Greater, you have like the or. So that can help you determine which one to use. So I'm going to use an absolute value. I'm going to use my variable of x. The middle number between 0 and 4. If I did 0 plus 4 and divided by 2, that gives me 2. So 2 is the middle number. So that'd be x minus the middle number, which is 2. Since this is connected, that's an and, so that's less than. These are open circles, so it cannot equal those. And how far away is 2 from 4? That is 2 steps away. So now here's my inequality, or my absolute value inequality. The absolute value of x minus 2 is less than 2. Now I can check to see if that works. If I put a number in that's less than 2, a number less than 2 would give me, let's say, put a 1 in there. 1 minus 2 is -1. The absolute value of -1 is 1. 1 is less than 2, so that would work. If I put 3 in there, 3 is on that solid line in between 0 and 4. So if I put a 3 in there, 3 minus 2 is 1. Absolute value of 1 is 1. 1 is less than 2. So therefore, this would be my absolute value inequality. Now my last two examples, I'm going to solve and then I'm going to graph them. Now to solve these absolute value, I'm going to have to make one positive and one negative when I take it out of the absolute value. So now I have m plus 5 is going to be less than 3. Less than means it's an and actually to save actually no, for this one I'll just use the keyword and then I have m plus 5 has to be greater than negative 3. So I have to flip the symbol because now I'm using a negative form. And remember when we had negative inequalities or divided by a negative number or multiplied by a negative number, we had to flip the symbol. So I'm just flipping the symbol here. And now I can solve. So for this one, I'm just going to subtract 5. And now I have m is going to be less than 3 minus 5 is negative 2. And here I'm going to subtract 5. And now have m is greater than a negative 8. So if I put open circles at negative 2 and negative 8, so it's less than negative 2, but greater than negative 8, here would be my equation, or my inequality and my, my solutions on the graph. In example 4, we're going to do the same thing here. This one is a greater, so greater, think of or, so I'm going to write two inequalities. I'm going to put this up here so I have a little more space. So I have k minus 4 is greater than 3, or k minus 4 is less than, and I use the negative form, negative 3. Okay, now I'm going to solve for k by adding 4 to both sides, and I have k is greater than 7, or here I add 4, and I have k is less than 1. Since I'm just having greater than and less than symbols, I have an open circle. So open circle at 7, open circle at 1, and it's got to be greater than 7, or it's going to be less than 1. And since they're going in opposite directions, they're not connected. That's why we have the keyword or. So that is how you can solve absolute value inequalities.